Hi there guys, welcome to my walkthrough of the Edexcel New AS Level Maths Sample Paper 1 walkthrough. So this paper is pure mathematics, paper 2 will be statistics and mechanics and will be linked down below. So I'm going to link the paper down there and the formula booklet as well as all of my AS chapter playlists and every past paper, specimen paper and sample paper up to now for AQA, Edexcel and OCR. So at the moment, given that we don't have very many past papers for the new spec, I highly advise trying to do all papers from each exam board. It's all relevant and it makes really good practice. Okay, let's do this. Okay, question 1. The line L passes through the points A, 3, 1 and B, 4, minus 2. Find an equation for L. Okay, so general equation of a straight line is y is equal to mx add c, where m is the gradient and c is the y-intercept. Now we need to find the gradient first, so gradient is difference in y, just shorten to dy, over difference in x, so dx. Now, the difference in y then, let's do minus 2 minus 1 over 4 minus 3. Now minus 2 minus 1 is minus 3. And on the bottom, 4 minus 3 is just 1. So our gradient is just minus 3. So now we know y is minus 3x add c. Now to find the value of c, we use one of the sets of coordinates. So I'm going to use 3, 1. So that tells us when x is 3, y is 1. So we get 1 is minus 3 times 3, which is minus 9, add c, therefore c is equal to 10, and that means then that y is equal to minus 3x add 10, boom. Okay, question 2. The curve C has equation y is 2x squared minus 12x add 16. Find the gradient of the curve at the point P, 5, 6. Okay, so the gradient of a curve is given by the gradient function which is dy by dx, so the first derivative. So our first job here is to differentiate. So dy by dx is going to be, so 2x squared differentiates to 4x, minus 12x differentiates to minus 12, and the 16 just differentiates to 0, so it disappears. So dy by dx is 4x minus 12. Now the gradient at P is going to be dy by dx when x is equal to 5. So that we can write as dy by dx of 5 is equal to, well, 4 times 5 is 20, so we get 20 minus 12, we get 8. Cool. Okay, question 3, we have vectors. So given that the point A has position vector 3i minus 7j, and the point B has position vector 8i add 3j, part A, find the vector A to B. Okay, so all that the i's and j's mean, i's just mean horizontal and j's mean vertical. So point A, for example, 3i minus 7j just means 3 to the right and 7 down. So you can think of these as coordinates, really. So the coordinates of A would be 3 minus 7, for example. Now we want the vector A to B. So A to B, well that's just B minus A. So that's going to be 8i add 3j minus 3i minus 7j. Okay, so we've got 8i add 3j minus 3i add 7j. So that's going to give us 5i, and then we got add 3j, add 7j, altogether then we've got 10j. So A to B is 5i add 10j. So 5 to the right, 10 up. Part B wants us to find the magnitude of A to B. Give your answer as a simplified set. So all that this means basically we're doing Pythagoras. We're just finding the length of the vector. So it's square root of 5 squared add 10 squared, which is square root of 125. Now we need to simplify that. So the square number that goes into that is 25. So we can write this as root 25 root 5. Root 25 is 5. So we've got 5 root 5. Cool. Okay, question 4, some polynomial fun. So f of x is 4x cubed minus 12x squared add 2x minus 6. We want to use the fact theorem to show that x minus 3 is a factor of f of x. So, by the fact theorem, f x minus 3 is a factor of f of x, then f of positive 3 will equal 0. So, let's find f of 3. Okay, so 3 cubed is 27, 4 times 27 is 108. Okay, 3 squared is 9, 12 times 9 is 108. So we got 108 minus 108. Two times 3 on a good day is 6. So we got add 6 minus 6. So that does indeed equal 0. Therefore, x minus 3 is a factor. Cool. Okay, then part B says, hence, show that 3 is the only real root of the equation f of x is equal to 0. Okay, so f of x is a cubic now cubics can either be written as the product of 3 linear factors, so I'm just going to say L times L times L, or a linear times a quadratic. So what we have found in part A is a linear factor of f of x. So we know then that f of x can be written as x minus 3 times some quadratic factor. So ax squared add bx add c. So what we need to do is find the values of a, b and c. So we then know the quadratic factor, and we can then check how many real solutions the quadratic has using the discriminant. So there's a few different ways we could do this, but we could use algebraic division. I'm going to compare coefficients, because I think it's probably the simplest way. So if we expanded x minus 3 times the quadratic, let's think about what x cubed term we would get. We would get a x cubed. Now that would be the only cube term. So ax cubed has to be identical to 4x cubed. So that means then that a is 4. Now we can find c just as easily. So the only constant term we would get when we expand this up is minus 3c. So that has to be identical to minus 6. So c is equal to 2. So now we know that for x can be written as x minus 3 times 4x squared add bx add 2. So now we need to find the value of b. So we can do this either by considering x squared terms or x terms. So I'm going to go for the x squared terms. So we would get minus 3 times 4x squared. So that's minus 12x squared. And we would also get bx squared. Now that has to be identical to the number of x squareds in the polynomial. So that's minus 12x squared. Now, if we divide through by x squared, we get minus 12 add b is equal to minus 12. Now this tells us that b is equal to 0. So now we know the quadratic factor is 4x squared add 2. So, if we now want to check how many factors or roots that has, we can use the discriminant. We wouldn't really need to here because we can see this is always going to be positive. So it's never going to equal 0. which is what we would need for there to be roots. The reason it's always going to be positive is x squared is either always going to be positive or 0, so we're always adding 2 to a positive or 0 number. But let's use the discriminant to prove it. So there's that. The discriminant is b squared minus 4ac. So for us here, a is 4, b is 0, and c is 2. So the discriminant is going to be 0 squared, 0, 0, minus 4 times 4 times 2. So that's minus 16 times 2, that's minus 32. Which is less than 0. So a discriminant less than 0 implies no real roots. Therefore, x minus 3 is the only factor of f of x. And therefore 3 is the only real root. Cool. Okay, number 5, given that f of x was equal to 2x, add 3, add 12 over x squared for x greater than 0, show that the integral between 1 and 2 root 2 of f of x with respect to x is equal to 16 add 3 root 2. Okay, so first thing we'd want to do here is rewrite f of x, writing 12 over x squared in power form. So f of x is 2x add 3 add 12x to the minus 2. Okay, so now we're going to integrate this. Let's put the limits in as well, so between 1 and 2 root 2. Okay, so remember when you integrate, power of x goes up by 1 and you divide by the new power. So if we integrate 2x, we're going to get 2x squared over 2. So that's just x squared. Constants just integrate to that constant times x. So 3 becomes 3x. And then 12x to the minus 2, well the x to the minus 2 becomes x to the minus 1. and then we divide by minus 1. So we get minus 12 x to the minus 1. Now, I'm just going to rewrite that now back as a fraction. So that's minus 12 over x between 2 root 2 and 1. Okay, so now we substitute the limits in. So first we put in x is 2 root 2. So we get 2 root 2 all squared. Add 3 times 2 root 2, so that's 6 root 2. And then we get 12 over 2 root 2. The 2's cancel. So we get 6 over root 2 minus 6 over root 2. Why have I got a bracket? Okay, so that's our first bracket. And then we subtract what we get when we substitute x equals 1. So this is a lot nicer. 1 squared is 1. Add 3 times 1, that's 4. And then we got minus 12 divided by 1, so that's minus 12. So we've got 4 minus 12, that's minus 8. Okay, that's the first bracket. When we square 2 root 2, we get 2 squared times root 2 squared. So 2 squared is 4, root 2 squared is 2. So we get 8, add 6 root 2. Now what we need to do over here is rationalise the denominator. So we're going to multiply the top and bottom by root 2. So we get minus 6 root 2 over 2. Now the 6 and the 2 cancel. So we get minus 3 root 2. And then we got minus 8. So that's add 8. Okay. So we've now got 8 add 8, which is 16. And then we got 6 root 2 minus 3 root 2, that's 3 root 2. So we've shown what we needed to, put a little end of proof, or if you like, cheeky little QED, quite enough, done. Okay, question 6. We want to prove from first principles that the derivative of 3x squared is 6x. So we are given the formula for first principles in the formula booklet. If you haven't got this yet, it's linked down below. Make sure you have a look and know what's in it before you do your exams. So, first principles is here. So, f dash of x, the derivative of f, is the limit as h tends to 0 of f of x at h minus f of x all over h. So, what we need to do is find f of x at h. So what that means is, in our function 3x squared, I suppose we should first of all say let f of x equal 3x squared, then we can find f of x and h. So remember, composite functions from GCSE, this is that. So the x in 3x squared becomes x add h. So we get 3 lots of x add h squared. So that's going to be 3 lots of, remember, x add h squared means x add h times x add h. So we get x squared add 2x h add h squared. So that's 3 in, and then we get 3 lots of x squared add 6x h add 3h squared. Okay, so now we can start thinking about the derivative. So f dash of x is the limit as h tends to 0 of 3x squared add 6xh add 3h squared minus 3x squared all over h. Now, what always happens here is on top, the terms without a h cancel out. So we got a 3x squared and a minus 3x squared. So they go bye bye. So we get left with f dash of x is equal to the limit as h tends to 0 of 6xh add 3h squared all over h. Now this, if you've never seen these before, these are called ditto marks, and they're used when you have to keep writing the same thing over and over again. So there, instead of writing f dash of x again, I just put ditto marks, which means the same as above. So now the factor of h can cancel, so we get left with 6x add 3h. Now, as h tends to 0, um, 6x add 3h. So essentially what we do when we say tend to 0, really you can think of it as saying just h is 0. Just means as it gets incredibly small, it becomes negligible, so we can just ignore it, think of it as 0. So 6x add 3h tends to 6x, therefore the derivative of x at f is 6x cubed. Okay, number 7 is binomial expansion, part A. Want us to find the first 3 terms in ascending powers of x of the binomial expansion of 2 minus x over 2 to the power of 7, giving each term in its simplest form. Okay, so we are given the binomial expansion formula in the formula booklet. To be honest though, I think that complicates things. So, the first term is always the first term in the bracket to the whole power. So, first thing we're going to get is 2 to the power of 7. Now if you like, it might help with the pattern if we also put a minus x over 2 to the power of 0. Then the next term is the power choose 1. So 7 choose 1. Now the power of 2 goes down by 1. So we get 2 to the 6. And then the power of minus x over 2 goes up by 1. So we got that to the power of 1. Now the next term is the power choose 2. So 7 choose 2. Now the power of 2 goes down by 1 again. So we now got times 2 to the power of 5. And the power of minus x over 2 goes up by 1. So we got minus x over 2 squared. So those are the first 3 terms. Now we need to simplify. So 2 to the power of 7 is 128. Minus x over 2 to the power of 0 is just 1. So the first term is just 128. Now 7 choose 1 is 7. 2 to the power of 6 is 64. Minus x over 2 to the power of 1 is just minus x over 2. And then our third term, 7 choose 2 is 21. 2 to the power of 5 is 32. And minus x over 2 all squared is x squared over 4. Okay, so we have 128. Okay, so 64 times minus x over 2 is minus 32x. So we got 7 times minus 32. So you can use your calculator. 7 times 30 is 210. 7 times 2 is 14. So we get minus 224x And then the third term, well, 32 times x squared over 4 is 8x squared. So then we need 21 times 8, which is 168x squared. So there are the first three terms. So we can say 2 minus x over 2 to the power of 7 is approximately 128 minus 224x. Add 168x squared. Cool. Okay, then part B for 1 mark wants us to explain how we would use our expansion to give an estimate for the value of 1.995 to the power of 7. So, it's only 1 mark, so remember that our expansion is 2 minus x over 2 to the power of 7. So, what we would do is set 2 minus x over 2 equal to 1.995. We would then solve for x. And then substitute the value for x into the expansion. Cool. Okay, number 8. A triangular lawn is modelled by the triangle ABC as shown in figure 1. The length AB is 30 meters long. Given that angle BAC is 70 degrees and angle ABC is 60 degrees, part A, calculate the area of the lawn to 3 sig figs. Okay, so looking at the triangle, the first thing I would do is fill in the missing angle. So 60 add 70 is 130. So this top angle is 50 degrees. Now we're going to need to use two types of trigonometry here. We're going to need the area of a triangle, and I'm also going to use the sine rule. So if you're rusty on your formulas, my formula video is linked down below. So area of a triangle, if you know an angle and you know two side lengths coming out of that angle, the area is 1/2 AB sine theta. Now the problem here is that we don't know two sides, so we're going to need to use the sine rule to work out one of the other two sides. So the side I'm going to go for no reason at all, is this guy. So using the sine rule, I can say that x over 70 x over sine 70 is equal to 30 over sine 50. From that, I can get that x is equal to 30 sine 70 all over sine 50, which 236 gives me 36.8 meters. So, now that I know that length, I now have an angle with the two side lengths coming out of it. So, I can work out the area. So it's going to be 1/2 times 30 times 36.8 times sine of 60. Now that 236 gives us 478 meters squared. Cool. Okay, and part B asks, why is our answer unlikely to be accurate to the nearest square meter? So, bit of a strange one. I think what I would go for is it's highly unlikely that the angles in this garden are going to be exactly 60, 70 and 50. It's probably highly unlikely the sides are going to be exactly straight. Highly unlikely that this bottom length is exactly 30 meters. So that is obviously going to have an effect on the answer. We could also say that the garden might not be flat, it might be on a hill, or it might be curved. That's going to also affect the area. Something along those lines, and you're golden. Okay, question 9, a nice trig equation. So we want to solve for x greater than or equal to 360 but less than 540. 12 sine squared x add 7 cos x minus 13 is equal to 0. Giving our answers to one decimal place, solutions based entirely on graphical methods will not get marks. So, as always with trig equations, we want to get this in terms of just one function. So we're going to need to use sine squared add cos squared is equal to 1. So we can use that to get rid of the sine squared. So sine squared is 1 minus cos squared of x. So our equation is now 12 lots of 1 minus cos squared of x add 7 cos x minus 13 is equal to 0. Okay, so if we expand the bracket, we get 12 minus 12 cos squared of x, add 7 cos x minus 13 is equal to 0. So 12 minus 13 is minus 1, so we can write this as minus 12 cos squared of x, add 7 cos x minus 1 is equal to 0. So, the problem that we've now got is that we got a negative cos squared term. It's not really a problem, it's just not very nice. So, to get out of that, we're going to multiply everything through by minus 1. So we're then going to get 12 cos squared minus 7 cos, add 1 is equal to 0. Okay, so now we're going to try and factorise this. So, given that we got a positive 1 at the end, but a negative term in the middle, that tells us both constants inside the brackets are negative. And there's only, luckily, one thing that multiplies together to give us 1, and it's 1. So both brackets are going to have a minus 1. So then to get the 12 cos squared, we're going to need 3 cos and 4 cos, which luckily also gets us the minus 7 cos in the middle. So, from that, we now set what is inside each bracket equal to 0, and get cos x on its own. So, if 4 cos of x minus 1 is equal to 0, that tells us cos of x is equal to 1/4, or if 3 cos of x minus 1 is equal to 0, that tells us cos of x is equal to 1/3. So, now we need to solve these equations. So remember the interval we are in between 360 and 540. So let's make a sketch of cos of x. So, between 0 and 360, cos looks like that, but we're not interested in values in that interval. So the next 180 degrees looks like this. So it's on the green part of the graph where we are interested. In solutions. Okay, so let's deal first of all then with cos of x is equal to 1/4. So that tells us x is the inverse cos of quarter. Now that is going to give us 2 seconds. So that gives us 75.5 degrees. Now we're not interested in that. What that's given us is this value here. So this is 75.5 degrees, and this is a quarter. So again, we're not interested in that value. We want the one that's all the way over here. So this one. Now, cos has a period of 360 degrees, so this value is 75.5. Where are we going to do it? Add 360 degrees. So that is going to give us 435.5 degrees. Okay, if we then do the same with a third, so if cos of x is equal to a third, x is the inverse cos of a third, which is going to give us 70.5 degrees. Now again, that's giving us the solution back here. So we don't want that one, we want the one over here. So that's again 360 at 70.5, which is 430.5 degrees. So there are our two solutions. Cool. Okay, number 10. The equation kx squared add 4kx add 3 is equal to 0, where k is a constant, has no real roots. Prove that k is greater than or equal to 0, but less than 3/4. Okay. So, first step. Let's see what would happen if k was 0. So, if k is equal to 0, then we're left with 3 is equal to 0. So, that makes no sense at all. So, there are no roots when k is equal to 0. So that's where the or equal to part of that part of the inequality is going to come from. Now for the rest of it, this equation is quadratic. So, for no real roots, the discriminant b squared minus 4ac is less than 0. So, for us, a is k, b is 4k, and c is 3. So, that means that 4k squared minus 4 times k times 3, so minus 12k, has to be less than 0. Now, four k all squared is 16k squared. So 16k squared minus 12k is less than 0. Now we can divide through by 4, not the k though, because you lose solutions, or a solution. So divide through by 4, we get 4k squared minus 3k is less than 0. Okay, so now we think about this as an equation. So we now think of 4k squared minus 3k is equal to 0. The reason being, we're now going to find the points where the graph of this would cut the x-axis, so where it's equal to 0. So, we can factorise and get k lots of 4k minus 3 is equal to 0. So that tells us then the graph of this is 0 when k is equal to 0 or k is 3/4. So the graph looks like that. Now remember, we need it to be negative. So we want this part down here. So from that, we can see then that 4 4k squared minus 3k to be less than 0, k needs to be greater than 0, but less than 3/4. So remember what we said at the start as well, k can be equal to 0 and there's no real roots. So, therefore, k is greater than or equal to 0, but strictly less than 3/4. Cool. Okay, number 11. So we got quite a tricky proof question here, but it's only worth 2 marks. Pretty tight. So we want to prove that for all positive values of x and y, root xy is less than or equal to x and y over 2. So, there are really 2 ways to do this, neither one is obvious. So, the way that I think about it is, how can we start to get an inequality involved? So, because x and y are positive, we know then that x minus y could be positive, negative, or 0. But if we square that, well, we know that that then can't be negative. So that then is either positive or 0. So we can say now that's greater than or equal to 0. So we've now got an inequality. If we expand the brackets, we get x squared minus 2xy add y squared greater than or equal to 0. Now if we add 2xy to both sides, x squared add y squared is greater than or equal to 2xy. Now think about what we're trying to get. We want an x add y. We can't factorise x squared add y squared, but we almost can. If we added 2xy to both sides, we get x squared add 2xy add y squared is greater than or equal to 4xy. We can then factorise the left hand side to x add y squared, so that's greater than or equal to 4xy. We can then square root, so x add y is greater than or equal to root 4xy. Root 4xy is 2 root xy. So x add y is greater than or equal to 2 root xy. Divide through by 2. X add y over 2 is greater than or equal to root xy. Boom. Okay, so as I said, not obvious and not simple. Part B, for 1 mark, wants us to prove by counterexample that this is not true when x and y are both negative. Okay, so let's just say x is equal to y is equal to minus 1. Then root x y is the square root of minus 1 times minus 1, which is the square root of 1, which is 1. And x and y over 2 would be minus 2 over 2, which would be minus 1. So here, root xy is greater than x add y over 2. So there we have our counterexample. Okay, number 12. A student was asked to give the exact solution to the equation 2 to the power 2x add 4 minus 9 lots of 2 to the power x is equal to 0. We're given the student's attempt to solve the equation. Part A wants us to identify the two errors made by the student. So, let's have a closer look at what we've done. Okay, so we've started by writing down the equation, always a good move. Then we've turned 2 to the power of 2x add 4 into 2 to the power of 2x add 2 to the power of 4. So this is one of the errors. So let's write down. First error is that 2 to the power of 2x add 4 by the rules of indices is 2 to the power 2x times 4 times 2 to the power of 4, not 2 to the 2x add 2 to the power of 4. So that is the first error. Okay, at that point they then said let y equal 2 to the x. So that's alright, because 2 to the x times 2 to the x is 2 to the 2x. So 2 to the 2x is y squared. So that's alright. But then we've got this 8. Now the 8 has come from the 2 to the power of 4. So there's the second error. Two to the power of 4 is 16, not 8. Cool. Okay, then part B wants us to find the exact solution to the equation. Okay. So we've said then that 2 to the power of 4 is 16, and we don't get 2 to the 2x add 2 to the 4, we get 16 times 2 to the 2x. So we get 16 times 2 to the 2x minus 9 times 2 to the x is equal to 0. So now we're going to make the same substitution that this person did. So let y equal 2 to the power of x. Then we've got 16y squared minus 9y is equal to 0. Now it might be tempting here to divide away the common factor of y. Never do that though, because it loses a solution. So factorise instead. So we get y lots of 16y minus 9 is equal to 0. So either y is equal to 0 or 16y minus 9 is equal to 0. So y is equal to 9/16. Now that means that 2 to the power x is equal to 0 or 2 to the x is equal to 9/16. Now, on the left, 2 to the power of x cannot equal 0. It's an exponential. So whatever value of x we substitute in, 2 to the power x equals 0 has no solutions. So that means then the solution has to come from 2 to the power of x is equal to 9/16. So we're going to get logarithms involved. So to cancel out a base of 2, we need to take the log base 2 of both sides. So x is log base 2 of 9/16. Cool. 13a wants us to factorise completely. X cubed add 10x squared add 25x. Okay. So this is a cubic. So x cubed add 10x squared add 25x. Okay, so first up there's a common factor of x. So we can say this is x times x squared add 10x add 25, and then we can factorise that quadratic to x add 5 times x add 5. So we can say that's x add 5 squared. Cool. Okay, part B wants us to sketch the curve with equation y is equal to x cubed add 10x squared add 25x. Showing the coordinates of the points at which the curve cuts or touches the x-axis. Okay, so So y is equal to our cubic. So y is equal to x times x add 5 all squared. So on the x-axis, y is equal to 0. So x lots of x add 5 squared is equal to 0. Now we've got two different types of a root here. So from the x, this is a distinct root. So that cuts the x-axis, and x add 5 squared is a repeated root. So that means it only touches the x-axis, doesn't actually cut it or cross it. So, forgot to put the values in. So x gives us a solution of x equals 0, and x add 5 squared gives us the other solution at x equals minus 5. So the graph, given that it's a cubic and it has a positive x cubed term, it starts in the bottom left and ends in the top right. So we're gonna start down here, hit the x-axis at minus 5, go down a bit, and go back up through x is 0, like that. There we go. So this is minus 5, and this is 0, and that is our graph of y equals x cubed add 10x squared add 25x. Okay, and for part C, the point with coordinates minus 3, 0 lies on the curve with equation y is equal to x add a cubed add 10 lots of x add a squared add 25 lots of x add a. Where a is a constant, find the possible values of a. Okay, so all that's happened here is the equation that we've been playing with in the first two parts has now just become y of x add a. So it's just a composite function. So if y is equal to x add a cubed add 10 lots x add a squared add 25 lots of x add a, we know that in factorised form that's x add a times x add a add 5 squared. Now, because we know that this point minus 3, 0 lies on the line, we can say that when x is minus 3, y is equal to 0. So that can give us minus 3 add a times minus 3 add a add 5, so that's 2 add a squared. Now we know that that is equal to 0. So either minus 3 add a is equal to 0, which tells us a is equal to 3, or 2 add a is equal to 0, so a is equal to minus 2. Cool. Okay, number 14, here we go then, nice big one. So, modelling with logarithms and exponentials. So we got this straight line graph. Going up the side, we have log 10 of p, and along the bottom, we've got t. So, a town's population, p, is modelled by the equation p is a b to the power of t, where a and b are constants, and t is the number of years since the population was first recorded. The line L, shown in figure 2, illustrates the linear relationship between t and log 10 of p for the population over a period of 100 years. Now we're told the line L meets the vertical axis at 0, 5, as shown, and the gradient of L is 1 over 200. Part A wants us to write down an equation for L. Okay, so it's a straight line, so we need to be thinking along the lines of y is equal to mx add c, except for us our y is log 10 of p and our x is t. So it's going to be log base 10 of p is equal to m times t add c. So we were told the gradient was 1 over 200. So we could say that log 10 of p is t over 200, and we were told we hit the vertical axis at 0, 5, so c is equal to 5. So there is our equation for L. Okay, then part B for 4 marks wants to find the value of A and the value of B. So remember that we know P is AB to the power of T. So we're going to do some magic to that formula to put it in the form log 10 of P is equal to something to do with A and B. Then compare it to the equation from part A. So, we know then P is A, B to the T. Now if we take the log of both sides, log 10P is equal to log base 10 of A, B to the T. Now by the rules of logs, we can split the right hand side into log base 10 of A, add log base 10 of B to the power T. And again, by the rules of logs, we can say that log base 10 of B to the power T is T log B. And then I'm just going to reorder that. I'm going to say log base 10 of P is equal to T log B add log A. So log base 10 of B is the gradient and log base 10 of A is the y-intercept. So log base 10 of A is 5. Now remember that means 10 to the power of what is equal to A, or A is equal to 10 to the power of 5, which is 100,000. So there's A, and we then know log base 10 of B is 1 over 200. Now that means B is 10 to the 1 over 200. Now that, if we go to 4 decimal places, just to be safe, is 1.0116. So there are the values of A and B. Now we don't need to do this yet, but we're probably going to need it at some point. So I'm now going to say that P is 100,000 times 1.0116 to the power of t. Cool. Okay, then for part C, with reference to the model, interpret part 1, the value of A, and part B, or part 2, sorry, the value of B. Okay. So, we found A to be 100,000. Now, 100,000 then is the number multiplying the term involving t. If t was equal to 0, then 1.0116 to the power of 0 would just be 1. So, t equals 0 gives us the time at which the population was first recorded. So, when t is equal to 0, we have the initial population. So, that is what the 100,000 represents. And for part 2, the 1.0116. Well, this is essentially compound interest, except instead of thinking about money, we're thinking about a population increase. So, if we multiply something by 1, we're just finding 100% of that number. If we put point something after the 1, we are increasing it by a certain percentage. So the 1.0116 is the proportional increase, I guess we could call it. So we could say the proportional increase. Now we could even say it shows so the increasing part is the bit after the decimal. So 0.0116 as a percentage is 1.16%. So it shows a 1.16% increase per year. Cool. Okay, then T part 1 wants us to find the population predicted by the model when t is equal to 100, giving our answer to the nearest 100,000. So, all that we're doing there is substituting in t is equal to 100. So, we're going to get P is equal to 100,000 times 1.0116 to the power of 100. Now this gives us 316,870 blah 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 to the nearest 100,000. That's 300,000 to the nearest 100,000. Okay, then T part 2 wants us to find the number of years it takes the population to reach 200,000 according to the model. So this time we set P is equal to 200,000 and solve for T. So we're going to get 100,000 times 1.0116 to the power of T is equal to 200,000 if we divide through by 100,000, 1.0116 to the power of T is equal to 2. Now if we take logs of both sides, doesn't matter what sort of log we use, so I'm just going to use ln. So if we do that, we get T log 1.0116 is equal to log 2. So T is equal to log 2 over log 1.0116. So it's really important to have a log on top and a log on the bottom. It's not log of 2 over 1.0116, it's log 2 over log 1.0116. So that to one decimal place gives us 60.1 years. You might get a slightly different answer depending on your rounding. Okay, then the final part E, says to state 2 reasons why this may not be a realistic population model. So, first one that springs to mind is that there is no cap on the model. So that suggests infinite population growth forever. So that can't be the case. So that'll be my first one. Second one is it's assuming that the rate of growth of the population remains the same from year to year, which is quite unlikely. Either as the population gets bigger, the rate of growth is going to speed up or slow down. Another one is that the model is being used for a period of time of 100 years. 100 years is quite a long time. Something might happen to the whole town to wipe it out, like maybe disease or an asteroid, something like that. So there's 3 reasons, anything along those lines, and you're cool. Okay, number 15, a nice 8 marker, so probably really easy. So the curve C1 shown in figure 3 has an equation. Y is 4x squared minus 6x add 4. At the point P 1/2 2 lies on C1. The curve C2, also shown in figure 3, has equation y is 1/2 x add log of 2x. The normal to C1 at the point P meets C2 at the point Q. We want to find the exact coordinates of Q, and again, solutions based entirely on graphical or numerical methods are not acceptable. Okay, so 8 marks, big question. So let's think about this. The normal to the curve C1 at point P meets curve C2 at Q. So at that point Q, the equation of the normal and the equation of C2 are simultaneous. So they got the same x coordinate and the same y coordinate. So what we need to do is find the equation to the equation of the normal to C1 and then set that equal to the equation of C2 or solve them simultaneously. So first step then, let's find the normal. So a normal is a line perpendicular to a curve at a particular point. So if we find the gradient of the curve, we can find the gradient of the tangent. So y then is 4x squared minus 6x add 4. Now, to find the gradient of a curve, we need to differentiate. So, dy by dx is 8x minus 6. Now the gradient of C1 at P is dy by dx when we substitute in the x coordinate. So when we substitute in 1/2, so 1/2 squared is irrelevant because we're not squaring anything. So 8 times 1/2 is 4, minus 6 is minus 2. So that's the gradient of C1 at point P. Now, the gradient of the normal times the gradient of the curve at this point is equal to minus 1, because the normal is perpendicular. So we now know minus 2 times the gradient of the normal is equal to minus 1. Therefore, the gradient of the normal is minus 1 over minus 2, which is positive 1/2. So, now we know the gradient of the normal, we can start finding the equation. So, general equation of a straight line is y equals mx add c. So we now know that y is half x add c. To find c, we substitute in the coordinates of x and y at a known point. So again, that's point P. So we know when x is a half, y is 2. So that gives us 2 is equal to a half times a half, so a quarter add c. Which tells us then c is 7 quarters. So the equation of a normal, let's take it on to the next page. So the equation of the normal is y is equal to half x add 7 quarters. Cool. Okay. So, as I said before, at intersection points, lines and curves are simultaneous. So, C2 has equation half x add log of 2x. So, for both of these, we know y is equal to these expressions in x. So, because we are thinking about their intersection points, these equations are equal. So, at Q, we can say that 1 half x add 7 quarters is equal to 1 half x add log of 2x. Now we can solve this for x. So, if we take away the half x from both sides, we get 7 quarters is equal to log of 2x. To undo the log, we then need to exponentiate both sides. So e to the 7 quarters is equal to 2x. Therefore, x is equal to 1 half e to the 7 quarters. So that is the x coordinate. Now we need to find the y coordinate. So for that, we can use either equation. The normal one looks nicer. So we now know that y is 1 half so y is 1 half x. So that's 1 half times 1 half e to the 7 quarters. So that's a quarter e to the 7 quarters. Add 7 quarters. So, finally, the coordinates of Q are 1 half e to the 7 quarters, 1 quarter e to the 7 quarters, add 7 quarters. Cool. Okay, number 16, another big one. So, figure 4 shows the plan view, so we're looking down from above, of the design of a swimming pool. The shape of this pool A, B, C, D, A consists of a rectangular section A, B, D, E joined to a semicircular section B, C, D as shown in figure 4. Given that A to E is 2x, E to D is y, and the area of the pool is 250 meters squared, but show that the perimeter p meters of the pool is given by p is 2x add 250 over x add pi x over 2. Okay, so something to note here straight away. In what we're trying to show, there is no y. So, we can find the perimeter with y involved pretty easily. So we know that this is y meters as well. Now to find the arc of the semicircle, we know the diameter of the semicircle is 2x. Circumference is pi times diameter, so arc of a semicircle is pi times diameter over 2. So the arc is just pi x. So up to there we can say that the perimeter is 2x add 2y add pi x. So let's write that as 2x add pi x add 2y. So what we need to do is find an expression for y in terms of x. Now that is where the area is going to come in handy too. So we know the area in total is 250. The area of the rectangle is going to be 2xy. Now the area of the semicircle, or the area of the whole circle, would be pi times x squared. We've only got the semicircle, so it's pi x squared over 2. So we know the area is 2xy. Add pi x squared over 2. Now we also know that is equal to 250. So what we can do now is get y on its own. So if we divide through by 2x, we get y. We're not going to do that yet, sorry. We're going to subtract pi x squared over 2. So 2xy is 250 minus pi x squared over 2. Now, if we divide through pi 2, first of all, xy is 125 minus pi x squared over 4. And then, if we divide through pi x, y is 125 over x minus pi x over 4. So we're now going to substitute this into our perimeter. There. So our perimeter is now 2x add pi x add 2y. So add 2 lots of this stuff. So add 2 lots of 125 over x minus pi x over 4. So that's going to give us, okay, I'm going to run out of room, so just going to do this expansion here. So 2 lots of 125 over x is 250 over x, and 2 lots of minus pi x over 4 is minus pi x over 2. So this is going to give us 2x, then we got pi x minus pi x over 2, so that's pi x minus half pi x. That's going to leave us with pi x over 2, and then add 250 over x, which is what we wanted. Cool. Okay, part B wants us to explain why x is greater than 0, but less than the square root of 500 over pi. Okay, so for this, remember that x and y are lengths. So they must be greater than 0. Now that takes care of why x is greater than 0. Now if y is greater than 0, that means our expression for it in terms of x also has to be greater than 0. So 125 over x minus pi x over 4 has to be greater than 0. Now, if we multiply through by 4, we get 500 over x minus pi x is greater than 0, multiplied through by x, 500 minus pi x squared has to be greater than 0. Add the pi x squared. 500 is greater than pi x squared. Divide through by pi. 500 over pi is greater than x squared. Therefore, x has to be less than the square root of 500 over pi. Therefore, x is greater than 0 but less than root 500 over pi. Cool. Okay, then part C wants us to find the minimum perimeter of the pool, giving our answer to 3 sig figs. Okay, so for a minimum, we need to differentiate and set the derivative equal to 0, find the value of x, substitute that into the expression for the perimeter. Okay, so The perimeter then is 2x add 250 over x. So I'm going to write that in power form. So it's 2x add 250x to the minus 1, and then add pi x over 2. So if we differentiate that, we get 2. Now x to the minus 1 differentiates 2 minus x to the minus 2. So we get minus 250 over x squared. And then pi x over 2 differentiates to pi over 2. So, for a minimum, the derivative is equal to 0. So, 2 minus 250 over x squared add pi over 2 is equal to 0. Now we can add the 250 over x squared. So 2 add pi over 2 is equal to 250 over x squared. We could make it a bit less fiddly if we now multiply through by 2. So we get 4 add pi is 500 over x squared multiplied through by x squared. And then divide through by the bracket. X squared is 500 over 4 add pi square root, and we get x is equal to 8.37. So that is our value of x that gives a minimum parameter. So now we can find the minimum parameter by substituting in x is 8.37. So p when x is 8.37 meters is, now make sure that you can get this, we should get 59.8 meters. Cool. Okay, number 17, final question. So a circle C with centre at -2, 6 passes through the point 10, 11. Part A wants us to show that the circle C also passes through the point 10, 1. Okay, so general equation of a circle centered at a B with radius R is x minus a squared add y minus b squared is equal to r, the radius, squared. So, C then, because it has a centre, where is it, at minus 2, 6, we know that C is of the form x add 2 squared add y minus 6 squared is equal to r squared. Now, what we need to do is find the value of r. So, the way that we do that is we use the point 10, 11 because we know that lies on the circle. So, because 10, 11 lies on the circle, that means x is 10 and y is 11 satisfy the equation. So, when x is 10, y is 11, that gives us 10 add 2 squared, so 12 squared is 144. Add 11 minus 6 squared, so that's 5 squared, 25. So that tells us 169 is equal to the radius squared, therefore the radius is equal to 13. So C has equation x add 2 squared add y minus 6 squared is equal to 100, that's not, yes it is equal to 169. Now we want to show that this other point, 10, 1, lies on the circle. So if 10, 1 does lie on the circle, it will satisfy the equation. So when x is 10 and y is 1, we get 12 squared add minus 5 squared, which is again 144, add 25, which is 169, so 10, 1 satisfies the equation So lies on the circle. Cool. Okay, then part B for 7 marks. The tangent to the circle C at the point 10, 11 meets the y-axis at point P, and the tangent to the circle C at point 10, 1 meets the y-axis at point Q. We want to show that the distance PQ is 58, explaining your method clearly. Okay, so what we're going to need to do is work out the equation of each of these tangents, find their y-intercepts, and then find the distance between the y-intercepts. So, for this sort of question, I highly recommend making a sketch, which I've done here. So, the red line is our tangent at 10, 11. That meets the y-axis at point P, and the green line is our tangent at 10, 1, which meets the y-axis at Q. So, we need to find the equation of each tangent. So, the way that we do this is tangents are perpendicular to the radius at the point where the tangent hits the circle. So, let's do the red one first of all. So, the gradient of the radius there is difference in y over difference in x, remember? So, 11 minus 6, so 5, over 10 minus 2, so 10 minus 2 is 12. So that's 5 twelfths. Now, the gradient of the tangent is the negative reciprocal of the gradient of the radius. So the gradient of the tangent is minus 12 fifths. So the equation of the tangent then is of the form y is minus 12 fifths x and c. So we need to find c. To do that, we use the coordinates on the tangent. So 10, 11. So x is 10, y is 11. So we get 11 is equal to minus 12 fifths times 10. So 1/5 of 10 is 2. 2 times minus 12 is minus 24. Add C. So that tells us C is 35, and that is what we are really interested in. So we now know the y coordinate up here is 35. So we're now going to do the same for the green tangent. So the gradient of the radius here. Let's do 6 minus 1, so that's 5, over minus 2 minus 10, so that's minus 12, which is minus 5/12. So the gradient of the tangent is the negative reciprocal of minus 5/12. So that's positive 12/5. So now we know the tangent is of the form y is 12/5 x add c. Now we substitute again the coordinates that we know are on the tangent. So when x is 10, y is 1. So we get 1 is, so again, 1/5 of 10 is 2, times 12 is 24. So we've got 24 add c, therefore c is equal to minus 23. Again, that is really what we're interested in. So we now know the distance PQ is from minus 23 up to 35. So PQ is 35 minus 23, which is indeed 58. Boom. And on that, guys, paper 1 is done. Don't forget, check out the description for every past paper and specimen paper and sample paper up to now for AQA, Edexcel and OCR, as well as paper 2 from this and all of my AS content. Hope you find it useful. Don't forget, give us a thumbs up, get subscribed, share with your friends, take it easy, take care, have a great day.